Today we're going to be discussing about the mean, the median, and the mode of a set of values. When we've been talking about the mean, median, and mode, we have just been referring to measures of finding a central tendency. When we say central tendency, is more like a middle value or the center of a set of data which you have been given. Is more or less like a single quantity that represents the entire set. Just for example, in a class where you are being given a scores of each student, you could ask to say what must the mean score of all the students, which was the average score. Then the average score is more like that score that is representing the entire set, which could be taken as maybe the average, which is the mean, which could be taken as a mode, which is the one with the highest frequency. Let's say, for instance, 5 students score 70. You could say that 70 is the mode, which is now what's representing the score. Is the score representing what the set of other scores of students in the class? So it's 70. Now let's go into the definitions of each and every of these terms. When we talk about the mean, we have three types of mean. We have the arithmetic mean, the geometric mean, and the harmonic mean. But in this video, we'll just be covering the arithmetic mean. We'll cover the geometric and harmonic mean in the next video I'm going to drop. Now the mean, which is given as x, also known as the average, which is the arithmetic mean, is defined as a summation of frequency times the value x, value of a given set of data, which is x, over the summation of frequency. This summation fx means each frequency, the frequency of each value times what the value itself x, at which time is summation fx is now meaning the sum of the frequencies times the value. And we also have this is for a group data. And we also have that for an ungrouped data, which is the summation of the values of x over n, which is n is also the total number of values in a set, or the total frequency, which is n. Now, when you talk about a group data is one which has been arranged and classified. Let's say, for instance, we have a set of values from we have 8 set of values from maybe 1 to 10. This is the range of the values in that set. We could classify them in each class just to reduce the bulkiness. We might have to say maybe 0 to 5, then 5 to 10. You can see now that the class interval is this 10, this minus this. Use the class interval. The same as this 5 minus this, which is class. This is a group data. So in a group data, you might be seeing something like 0 to 10, 10 to 20, 20 to 30, and so on. But in an ungroup data, it's not arranged. It's just some not in an arrangement that doesn't look like it's ascending or descending. It's just random arrangement as an ungroup data. Now, if we were to go to a median, the median is actually mid-term, is a sample after which it has been maybe arranged in ascending order or descending order, which means when you give a set of values, raw data, you don't just find the median based on I was giving this like this, okay, this is the median, is the median, no. You have to arrange it in order either is in ascending order or is in a descending order. So that's middle term, that which is at the center. If I have 4, 5, 7, 8, the middle term now is, if I call this R, I 7 to be the middle term, and this is my median. Which is another form of central tendency. In some cases, I like using the middle value to represent the entire set. You can use a mean, you can use a median. Now, when you've been given to find the median of a set which is made specific, the measure of the number of sets is an odd number. The formula we're going to use to find the median is going to be the formula we're going to use median is going to be that the median value is going to be that which is at the center. And that's going to be the n over 210. When the values are odd, let's say the number of elements in the set is even, the median can be n plus 1 to 10. Now we also have calculating the median in a group data. You have a group data, you have there's just maybe a table is being created. You weren't actually giving the raw file or the raw data, so a table was more or less like created, and for you to calculate the median, let's say we're giving something 0 to 4 like I explained before, 0 to 5, 5 to 10, and so on, and you were given the frequency for 3. Now you don't actually know, like from this 0 to 5, you don't know if maybe all the values there are 3, 3, 4, 4, or if it was 2, 2, 3, 4. We're just giving it in a table like this. Now how are we going to calculate the median? Now the formula for calculating the median in such a case is given by the median value is going to be equals to lower class boundary plus n over 2, which is n refers to the number of elements in the set of number of values minus the frequency, cumulative frequency below the median class over the frequency of the median class times class C. Like I said, C is the first class, L is the lower class boundary. The n over 2 is the median value, which is n is the number of values in the set. F C is the cumulative frequency below the median class, and F is the frequency of the median class. So if you're going to look at some examples, let's take this video. Now going on to the mode is actually a simple and the simplest form of central tendency. Is that value that has the highest frequency. Let's say, for example, in a class of maybe 60 students, maybe 20 say they prefer to do mathematics, 10 say they prefer to do chemistry, 15 say they prefer to do physics. And let's say 15 say they prefer to do biology. Now in this case, the maths has more people. More people prefer to study mathematics, isn't it? And this means this is the mode of the class. If someone that, okay, in this class, most of the students love mathematics because it's the mode, so it's easy to use that value, that's such a value, so easy to represent all the sets of values in that set. Let's say the mode. When you're given a group data, the mode is quite simple. The mode is given to be lower class boundary plus difference in frequency of the class preceding the modal class. That's delta 1, which is change in frequency. Then delta So it's change the frequency of class after modal class times c. You can actually go back to looking at the next one. We are being told to calculate arithmetic mean, the mode, and the median of the set of values. Now, when you use examination, or maybe probably you're not doing a theory, maybe you're just doing a multiple choice question, which is maybe an objective question, a computer based question. You might be given such a question like this. It's kind of hectic. Drawing the table, time is also time wasting. When you probably have an account that so like 5 questions, you probably done one question to try to figure out your table. Well, it's quite a simpler form of solving the mean. Now for the mean, we're given that the mean is summation of the frequency times x over the frequency. Now from this formula, this is the frequency times what? Times the value of all of them. When you say summation is the total addition of each. So if I was to take the frequency times what? The value of all this, I sum it together, I'm going to have my summation fx. Now starting with this, I have 17. 17 is 1, 2. That means I have those to 17 instead. So the frequency is 2 times 17. Plus I have 218. That's frequency is 2 times 8. Plus 19 plus 21 divided by the total frequency, which is 1, 2, 3, 4, 5, 6, which is 6. I like ends up giving us let's work on that. Our answer is that's 110 divided by 6, which gives us this gives us 18.3, which means our mean in this case is 18.33. Now this is the arithmetic mean. Going on to calculate the mode. The mode is actually very simple. It's the one with high frequency. Those with the highest frequency are to 17 and 18, which means 17 and 18 is actually the mode, and this is said to be bimodal. Going on to calculate the median value. First, we're going to arrange it. It's really arranging the order in the question. We have 17, 17, 18, 18, 19, 21. Now, this is an even case, isn't it? There are different ways in which people calculate the median value. Some might tell you we have 6 of them. The 2 at the center, which is in this case, we cut this out, we cut this out, cut this out, cut this out. We have 18, 18. Some might tell you the median is going to be 18 plus 18 divided by 2, which gives us 18. Some might say the m plus 1 over 210. And this is 6 plus 1, that's 7 over 2, which is 3.510. Our triple of time 10 is estimated to be 410, which is also equals to 18. So it just depends on the way you solve for your median value. Okay, that's all for the example. Going on to the next example, I've been given okay, So this is a table. Yeah, when given a table of values to calculate for the mean, calculate for the median, also calculating for the model. Yeah, let's go ahead and solve this. Now looking at this question, this is actually a grouped data. We have the class interval, which is 10, which is 0 to 10, 10 to 20, 20 to 30 to 40, and 40 to 50. Looking at this, the class interval, well, you have 0 to 10, which I said we have 10 to 30. 10 to 20, 20 to 30, 30 to 40, 40 to 50, and the frequency, which is 5, 10, 15, 18, and 7. Now, this is the table. I haven't started solving this. Just write it down. Now, when you're given a group data, these are the values of x, which is actually the weekly age wage. Now we're given this, we can't just solve the mean, because we have to find a middle value, which is what actually the midpoint. Okay, the midpoint, middle value, or middle value, and what you go. Now the middle value in this case there is 0 plus 10, which is what equals 20 divided by 2, which gives us 10. So the middle value is going to be 10. The middle value is going to be 10 plus 20, which is 30 divided by 2, which is 15. Or I'm sorry, middle value here is 5. I'm sorry. Value here is 5. Middle value is 10 plus 20, which is 30 divided by 2, which is 15, which is 15. Middle value in this case is 20, that's 25. Keep on going, that's 35. That's 45. So we have the middle value. This is as simple as that. So going on to solve our mean is equals to summation fx over summation of the frequency. Now, as we did before, you're going to times our frequency times the midpoint value, or the mid value divided by the total distance. So going back to the table, we have 5 times 20, 5 times 5. This gives us 5 plus 10 times 15 plus 15 times 25 plus 18 times 35. Seven times 45. Now this is the frequency from this point. 55. We just have calculating this here. We have our value to be 1,495. Divided by 55. This gives us 27.18. So now this is our mean. In some cases, I prefer you just write it up to a number and we have to yourself. Simple. Now, calculating for the median. This is a group data. First of all, what we're going to do is we have to find where find when you remember, I told you that the value of the median is n over 2. I said that earlier. N over 2 is the total frequency divided by 2, which is 55 divided by 2, which equals 27.5. Now, when we look at 27.5, we can round it up to 28. That's good. Now, looking at this table, it means this is 20. The median is 27.510. That would the median mean. It doesn't mean this is the median. No. The median is going to lie in the 27.510. So that's 2810. So maybe if I was to arrange a set of values in ascending order or decreasing order, the value which appears to be the 2810 is going to be a median, which we're going to find out from the table. Looking at finding the class of the median value, we have the frequency in 0 to 10 to 5. That's lie there. Just we have 10 to 20, still not there. We have 20 to 30. Okay, from here to here, we see that there's a total frequency of 30. So which means it's definitely at this point in which the median value going to lie, which is going to be 20 to 30. So if you also ask what the median class is, median class. To 30, then our median value gonna be, it just says L plus. I said the L is a lower class boundary of the model class. Everything here also have to relate to the model class. The L is lower class boundary model class, which is going to be, this is 20. Is lower class, so that means lower class boundary is going to be 0.5 less of 20, which is 19.5. Plus our n divided by 2 is 27.5. I'm sorry, there's no enough space here. Let's put 5 plus 27.5. Now to calculate for a cumulative frequency below the median class, this is the median class, isn't it? Now the cumulative frequency below the median class is going to be all the frequency of the classes just before the median class, and we have 5 plus 10, which is gives us 15. So that means the value is going to 15. And the cumulative frequency of the median class actually from the table is what, 15. We have this times the class length, or the class length, the class width, the class size, all the same thing as C, is what, 10. This is the class 30 minus 20, or 20 minus 10, which is 10. So we have, using our calculator, we have this between 7.83. Let's say that's 28, which is almost very close to the mean, which mean we thought that the mean was 27.18. Very close. Now for the model class, the model class is going to be a class with the highest frequency, which is 30 to 40. The model class, they have the highest frequency of 18. And the mode is going to be L plus changing frequency first class. And that's going to give us the lower class boundary of the class is what's going to be 29.5 plus the difference in frequency of the class preceding it. If we were to go there, the first class is definitely going to be 18 minus 15 goes to 3. Change 1. change the frequency of 1, and for change it 2 is going to be 18 minus 7, which gives 18 minus 7 equals what? 11. So these are delta 2. So you're going back, delta 1 is 3, delta 2 is 11, and so that's it. We have solving that gives us just 1.64. So we have the mean, median, and the mode. So up equals to 27.18, the median, which is 28 approximately, and the mode, which is 32. I will be doing a video soon of more examples on the mean, median, and mode. Just drop the suggestion in the comment box. Don't forget to subscribe, like my page, turn on notifications, because I'll be posting a lot of contents, especially for science students and students who will be doing engineering. For that, I'll be posting more videos on those topics. So that's